You know, I've been digging into Kafka's throughput numbers again. The way it handles partitioning just seems to scale better than RabbitMQ.
But RabbitMQ has that new streaming plugin now, right?
Yeah, but let's be real. The maturity and community support around Kafka for large-scale distributed systems is hard to beat. Plus, with RabbitMQ, you end up tweaking settings a lot more.
Still, RabbitMQ feels like it might be easier to set up initially.
True, but once you hit those high concurrency use cases, Kafka's design really shines through. And don't even get me started on how Kafka Connect simplifies data integration tasks compared to setting up custom solutions in RabbitMQ.
So, do you think we should switch our project over to Kafka then?
It depends on your team's comfort level and existing infrastructure. If you're already deep into AMCP and have a robust setup with RabbitMQ, maybe stick with it. But if you foresee needing that extra oomph in scalability and performance, Kafka is definitely worth considering. Speaking of RabbitMQ, have you looked into the design patterns for message routing? They can make a big difference in how efficiently your messages are processed.
Not much. What kind of patterns are we talking about here?
Well, there are a few key ones like the publish-subscribe model, direct exchange, fan-out exchange, and topic exchange. Each has its own use case depending on how you want messages to be routed.
That sounds complex. How do you decide which one to use?
It comes down to what kind of messaging topology you need. For example, if you want each consumer to receive every message, fan-out is perfect. But if you need more control over who gets what based on specific criteria, topic exchanges offer flexible routing keys.
I see. So it really depends on the specific needs of the application?
Exactly. Getting this right from the start can save a lot of headaches later when scaling or maintaining the system. And don't forget about headers exchanges too. They provide another layer of flexibility by allowing routing based on message attributes rather than just strings. Speaking of efficient routing, let's talk about Kafka's architecture for a bit. It's designed to ensure high throughput, and understanding how it works can be really enlightening.
Sure, I've heard a lot about Kafka's efficiency but haven't dug deep into the specifics yet.
Well, Kafka is built around the concept of topics and partitions. Each topic is divided into multiple partitions, and these partitions are distributed across different brokers. This allows for parallel processing and ensures that you can handle a massive amount of data without bottlenecks.
That sounds like a smart approach. How does it manage to maintain such high throughput?
A big part of it is the way Kafka leverages log-based storage. Messages are written to disk in an append-only fashion, which is very fast and reliable. Additionally, consumers read messages sequentially, which minimizes seek operations and maximizes I/O efficiency.
Interesting. So, it's all about optimizing both writing and reading processes.
Exactly. And don't forget about replication. By replicating partitions across multiple brokers, Kafka ensures fault tolerance and availability. This redundancy also helps in balancing the load during failures or maintenance. Speaking of efficient processing, let's talk about best practices for implementing retries with RabbitMQ. It's crucial for handling transient failures without losing messages.
That sounds useful. What are some common strategies?
One effective method is using dead letter exchanges, DLX. When a message fails to be processed after a certain number of attempts, it gets sent to a DLX, where you can set up additional logic or manual intervention.
Dead letter exchanges sound like a good safety net.
Absolutely. Another practice is configuring retry policies directly in the consumer code. You can set exponential backoff delays between retries to avoid overwhelming your services during outages.
Exponential backoff makes sense to prevent overloading.
Definitely. And don't forget about setting up proper error logging and monitoring. This way, you can track failed messages and identify any recurring issues quickly. Combining these techniques ensures that your system remains robust and reliable under various failure scenarios. Speaking of robust systems, let's talk about using Kafka Connect to integrate external systems. It's a powerful tool for connecting Kafka with other data sources and syncs.
I've heard about Kafka Connect, but I'm not quite sure how it works in practice.
Kafka Connect provides a framework for building and managing connectors that move data between Kafka and other systems. For example, you can use it to stream data from databases, file systems, or even web servers into Kafka topics.
That sounds really useful for real-time data pipelines.
Exactly. One of the key benefits is its scalability and fault tolerance. Since Kafka Connect runs as a distributed service, it can handle large volumes of data and recover gracefully from failures.
And how easy is it to set up these connectors?
There are pre-built connectors available for many common systems, which makes setup relatively straightforward. You just configure the connector properties and deploy them to your Kafka cluster. Plus, the REST API interface lets you manage connectors dynamically without having to restart your entire system.
Sounds like a flexible solution for integrating various systems.
Definitely. Whether you're dealing with batch processing or real-time streams, Kafka Connect offers a scalable and reliable way to move data seamlessly between different parts of your infrastructure. Speaking of reliable data movement, let's shift gears a bit and talk about performance optimization techniques for RabbitMQ clusters. There are several ways to boost efficiency and reliability.
That would be great. What are some key techniques?
One important aspect is tuning the Erlang VM settings. Adjusting parameters like heap sizes and garbage collection strategies can significantly impact performance. Also, enabling the RabbitMQ shovel plugin can help distribute message loads more effectively across nodes.
Tuning the VM settings sounds technical but worthwhile.
Absolutely. Another technique is to use queues properly. By setting up mirrored queues across nodes, you ensure that messages are replicated and available, even if a node goes down. This improves both availability and fault tolerance.
Using queues makes sense for redundancy.
Definitely. Additionally, configuring network partitions correctly is crucial. Setting up the right policies can prevent split-brain scenarios where multiple nodes think they are the master, leading to data inconsistencies.
Configuring network partitions sounds critical for maintaining consistency.
Exactly. And don't overlook the importance of monitoring and logging. Tools like Prometheus or Grafana can give you real-time insights into cluster health and performance metrics, helping you proactively address any bottlenecks or issues before they become critical problems.